Okay guys, here we are. We're going to do Free Response 2004. This is the KSP problem. I know we haven't gotten through this fully in class today, for those of you watching this tonight, but we will finish this off on Tuesday or Wednesday, whenever I have you. Before we begin, KSP problem, do see a solid there, see an aqueous and an aqueous, along with the charges, along with the KSP, so we know it is a KSP problem. We're going to move right through this very smoothly. Right, the equilibrium constant expression. KSP is equal to concentration of the silver ion raised to the second power multiplied by the concentration of the chromate ion raised to the first power over 1. Very simple, straightforward answer to that problem. B. Calculate the concentration in moles per liter of Ag in a saturated solution, 25 degrees Celsius. That's going to be 298 Kelvin. You never know when that's going to come in handy. First thing, let's recognize that saturated means it's at equilibrium. Okay? So again, immediately we are going to set up our ice table for B. So here we go. Ag2 CrO4 solid breaks into 2Ag plus CrO4 2 minus, and these are both aqueous. Okay. Always set up your ice table. Always. Okay, this is not going to count because it's a solid. We know that the only direction a solubility reaction, a KSP problem, can shift is to the right. So initially there was nothing. There was no tang in the water initially. Pour the tang powder into the water, separates. This is going to be plus 2x because of that 2. This is going to be plus x because of that 1. You're going to get 2x, x for the equilibrium values. Remember, we can call these the saturated values. Call it X or something like that for KSP, whatever. So here we go. They want Ag, it's saturated, so that means Ag at equilibrium, so we're looking for 2x. Great thing about KSP problems is they always give us the KSP value. So since KSP equals concentration of Ag, second power, multiplied by the concentration of CrO4, 2 minus, we know that the value of KSP they gave us, 2.6 times 10 to the negative 12th, is equal to 2x squared multiplied by x, which is equal to 4x cubed. So the cubed root of 2.6 times 10 to the negative second divided by 4 equals x. So as you go through that and you do it, I believe you get 8.7 times 10 to the negative fifth, and you have to multiply that by 2. So our answer is 1.7 times 10 to negative fourth moles per liter. So this here is x, and this here is 2x, and x is the chromate value, the saturated chromate value, and 2x is the saturated silver value. Okay, for C, it says calculate the maximum mass in grams of silver chromate that can be dissolved in 100 milliliters of water at 25 degrees Celsius. Tricky problem here, so I'm going to have to erase this ice chart before we begin this problem. I'm having a little trouble erasing here, so I do apologize. Bear with me. Erase, 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 erase. How y'all doing today? Listen to my cough. Sounds gross, huh? Feel really weird because the janitor's in the room right now cleaning, and I'm writing and talking to myself and feeling like a complete dork, but that's what I get, I guess. Alright, so I'm back now. So, calculate the maximum mass in grams of Ag2CrO4. Okay, well, if you look at the reaction, Ag2CrO4 goes to Ag plus 2Ag plus CrO4 2 minus. What we could tell you is that the moles of CrO4 2 minus equal the moles of Ag2CrO4 from the balanced reaction. Okay, no big deal. That also means that the concentrations are gonna be the same. So we know that the value for X, which was CrO4, in this case, X was equal to 8.7 times 10 to the negative fifth moles per liter. Okay, that was X, which would also be the same thing as the AgCrO2 value. So we could say that 8.7 times 10 to the negative fifth moles of Ag2CrO4 are present in every 1 liter. Okay, what we're going to have to do first is, well, they want to know in 100 milliliters. So but they want to know grams. So why don't we convert this to grams first? In every 1 mole of Ag2CrO4, we have 2 Ags, 1 Cr, and 4 Os, giving us a molar mass of 33.300.7 grams. The moles are going to cancel. So now we have grams in every liter. We need to multiply this by, we want it per every 100 milliliters, which is the same thing as 0.1 liter. So that's going to cancel. And we're going to end up with our final answer, which is 0.0029 grams of Ag2CrO4. Yeah, kind of long problem there. Okay, so again, we recognize that the moles of chromate must be the same as the moles of Ag2CrO4. We had chromate, it was 8.7 times 10 to the negative fifth moles per liter. We converted that to grams per liter, and we multiplied by 0.1 to cancel out that value. We ended up with 0.0029 grams of Ag2CrO4. So yeah, that was the answer to C. We did that one right there. D, it says a 0.100 mole sample of AgNO3 is added to 1 liters of a saturated solution of Ag2CO4. So the saturated solution is at equilibrium. CrO4 2 minus. Will CrO4 2 increase, decrease, or remain the same? Now remember, adding Ag to AgNO3 is the exact same thing as adding Ag plus and NO3 minus, since nitrates are always soluble. NO3 is not present, so adding Ag plus 1 is the same thing as increasing the amount of Ag, which will shift the reaction to the left. So CrO4 will have to go down, will decrease. Now we're going to move on to the second part of this problem. And in the second part of this problem, basically, it gives you this setup, and it asks you to write the equation. Write a balanced equation for dissolving Ag3PO4 in water. Okay, so we have Ag3PO4. It's a solid. It's not going to count. We're going to get 3 Ag plus 1s this time, and 1 PO4 3 minus. So let's calculate the value for KSP for this one. I'm going to have to stop this podcast, and I'm going to get you started, and we'll come back and finish this. So I know that KSP, this is F, I'm doing right now, is going to be equal to Ag raised to the third power and PO4 minus 3 raised to the first power. That means that if you set up your ice chart up here, this doesn't count, 0, 0. This is going to end up being 3x and x. Okay, so that means that KSP is going to be equal to 3x to the third power multiplied by x. So KSP is equal to 9x cubed. We're going to get going back on this in a sec. Talk to you guys later.